My name's Brian Duff, and I lead the Android context team at Google. And I'm really thrilled that you're all here today and interested to learn more about how you can use awareness and nearby to make your applications more contextual. So all of us experience the world around us with our 5 senses. We see, we smell, we hear, we touch, and we taste. And we react to our world based on what we experience with those senses. And as we go about our life, we encounter many devices in our home, in our place of work, on the bus, and on the train. These devices that we have are really amazing. They have a huge array of sensors and capabilities. And just like us, they can sense many things about their world. They have a high-resolution camera so they can see. They have an audio system so they can hear and make sound. They have GPS so they can know where they are anywhere on the planet. They have a gyroscope, an accelerometer, and a compass so they can know how they're oriented and moving in space. All of these capabilities are what make this a smartphone. And these capabilities can also make our applications much smarter about what the user is trying to achieve and accomplish in our applications. However, as an application developer, sometimes making sense of all of these signals is harder than it should be, especially trying to get a more deeper and nuanced understanding of what the user is doing. So our mission on the context team is to try to take away as much of this complexity as we can, and to make it as easy for you as possible to understand the context of the user, and also to detect and communicate between devices that are around you. Last year at Google I/O, we announced the Awareness API. So awareness provides 2 powerful but simple concepts. The Snapshot API lets you query and poll contextual information around devices at any time. And the Fence API lets you set up the conditions that your application is really interested in and trigger behavior even when your application is running in the background. There are many APIs on Android that you can use to get this information, but the real power of the Awareness API lies in how you can combine various different signals together to get a really nuanced understanding of what the user is doing. For example, maybe it's not enough just to know that I'm at a specific place, that I'm at the coffee shop, but knowing what it is that I'm doing there, that I'm standing in line, can be really useful in providing a better experience for my users. Maybe by knowing that I'm standing in line, my app can tell me, hey, instead of waiting to be served, you could just order your coffee directly from the app. And then I can go sit down, hack some Kotlin in Android Studio, and wait for my coffee to be made. So you can see that sort of combining these signals together can provide richer, suggestive, and predictive experiences for users. One thing that's hard when you try to build this kind of experience is doing it in a way that's as cognizant of the user's battery power and resources as possible. So another great strength of the Awareness API lies in optimizing system resources as best as we can to achieve these kinds of things. Several years ago, we started the Nearby project. We had a really simple aim in mind with Nearby, which was to allow you to walk up and use devices in your life just the same way that you walk up and interact with people in your life. We were hoping that by building this technology and by building simple APIs around it, we would enable a whole new generation of proximity-enabled applications. So I got to admit something. When we first built this technology, it was actually really, really annoying. So we tried to use sound to detect that devices are in the same room as each other. And the early prototypes we built made this incredibly noisy, screechy sound that totally irritated all the teams that were sitting around us. So we took a step back, and we worked really hard on perfecting this technology, and we added radio technology as well. And we encapsulated all of this in a really straightforward API called Nearby Messages. Nearby Messages allows you to publish small amounts of information to the devices around you and transfer that information via the cloud. But Nearby and Awareness have one basic limitation. In order to use them, your application must be installed. Now, that doesn't really meet the goal of having people walk up to things and just use them. Sometimes the best possible experience that we can provide to users is in a site or an application that they don't even know about, let alone have installed. While you're here in Mountain View, if you still have time, I really recommend going to visit the Computer History Museum on Shoreline. They have a wide variety of exhibits from the early days of computer science. And whenever I go there and I stand in front of one of those exhibits, I really want to know more about it. And of course, I could read the little sign that's on there, or I could scan a QR code, or I could do an image search, or type a short URL into my phone. But it turns out the Computer History Museum have a really great app. And in that app, there's a wealth of information about each exhibit. There's even an audio tour that I can use to learn more from the experts about each item. So I didn't know about this app until fairly recently. But I really think it's a great experience if you can go to the Computer History Museum and just stand in front of one of those exhibits, and your phone can tell you, hey, there's an app available, help you to install it, and take you directly to the place in the app that's relevant for the thing you're standing next to. Last year at Google I/O, we introduced nearby notifications, which is a technology that allows you to attach sites and applications to real-world physical objects using Bluetooth Low Energy beacons. So I'm thrilled that you're all here and that you want to make applications more contextual. And I have 3 senior engineers from the team here who are going to talk about best practices for using these APIs. And we're really happy to announce some new features here at Google I/O. So to get started, I'd like to introduce Ryan Bavetta, who's going to talk about nearby notifications.
Thanks. Hey, my name's Ryan Bavetta. I'm a member of the Nearby Notifications team. Like Brian said, we introduced Nearby Notifications at I/O last year, and it's been a lot of fun seeing what you guys have been making with it. Today, I'm going to go and do an overview of Nearby Notifications. We'll talk about some of the features we've announced within the past year, and then we'll show you how you can make your own messages. Brian talked about how we can make these really compelling experiences that are based on contextual information. But one of the challenges we have is, how do we start this experience? Like you said, if the user can skip the line for coffee by using your app, how do we suggest this app to users without them having to type the query into the search box? Nearby Notifications provides a link for Android users to jumpstart this interaction and jump straight to the relevant page within your app, instant app, or website. Depending on your message's relevance and performance, we may, for example, light up the Nearby Quick Settings tile, display the message in the Nearby List view, or raise a min or low priority silent notification. So let's see what this might look like. The other day, I was at the Conservatory of Flowers in San Francisco. They have all these interesting plants, tons of flowers from all over the world. They have these great signs next to the plants that say the species name, and to find more information, visit this website. Now, you could take out your phone, type in the URL, www.conservatoryofflowers.com.org.com goes somewhere else, /lowland. But wouldn't it be great if instead you got this link to jump straight to the content you want? This provides more information about the plants in that gallery. What could be better than this? If it provided information about the particular plant you're standing in front of. Now, this kind of installation is ambitious, but it's possible. The finer the context, the richer the experience we can provide. Now, looking a little later into this tree's life cycle, if we're at the lumber department of your local home improvement store, and you're trying to decide between a 1x6 or a 2x6 or a cedar plank, pine, it'd be really great if there were an associate nearby. We can provide a link to get to page an associate for that particular department. That would be cool. Another interesting use case we found is with device setup. Right now, when you buy a Chromecast and plug it in, we provide this notification to allow you to jump straight into the app to set up the device. If you don't have the app, the Google Home app, it brings you to the Play Store, where you're offered the opportunity to install the app and then continue right into the right part of the app to continue the setup. Another interesting use case is with instant apps. There's a demo right today in Dome C at the Instant App booth, so check that out later, where they have a little birdhouse. The birdhouse is a stand-in for an actual home for sale, and it's advertising a link to the detail page of the Instant App. This is an amazing way to get people access to the rich content that's deep inside your app without the user having to actually install the app. So how do all these scenarios work? These use cases rely on the phone detecting a Bluetooth low energy beacon nearby. Beacons are typically small battery-powered units like this, but they could also be devices acting as beacons, such as the Chromecast we talked about. What we do is join the code broadcast from the beacon to the text that you'd like to be displayed. But we don't want to show messages to uninterested parties, so targeting is really important. Over the past year, we've introduced several ways so that you can target and fine-tune the context of your message to only show it to these interested people. We've introduced targeting for time of day, day of week, app install state, that's whether your app is installed or not. And we're announcing today distance targeting, which is the distance to the beacon. This, alongside good placement of your beacons, helps make sure you're targeting the right devices. Bad interactions, like messages that go ignored or are muted, may be reasons that we may not show your message as a notification. Targeting the right users can sometimes involve stopping the broadcast. For example, device setup messages are great, but if your device hasn't been set up within about 15 minutes, the user probably isn't going to be setting it up anytime soon. So you should stop the broadcast. Let's talk about the text of your message. When deciding how to phrase your message, it's really important to be concise. You don't have a lot of characters available. We found that about 40 is the maximum where you can ensure that your message is displayed entirely. You should use strong context. In this case, we're looking for users that are waiting in line to order. And we should make it clear what will happen when the user taps on the message. In this case, the user will view a menu or place an order. Contrast this with a message like, "Come inside our store," or "Sale going on now." These messages are likely targeted to uninterested users, and the user doesn't know what will happen when they tap on the message. If you want to test an attachment, make sure to create the message in debug mode. Debug mode messages only show on debug mode devices. Oh, we're not. Is that for me? Turning on debug mode on your device also enables detailed bug reports, which are really helpful when debugging. Now, how to add messages to beacons. There are two ways. The first way, the beacon can broadcast the URL directly. We'll automatically pick up the title and the fave icon from the destination web page. This is the easiest way to get started. But you won't be able to set targeting for your message, like time of day or distance. To do that, you can have your beacon broadcast an ID, and then tie that ID to the message using the Beacon Tools app and the Beacon dashboard. This message also allows you to specify an app intent to be launched. Both of these methods allow you to specify a URL that launches an instant app. For details of the setup process, check out our website. Again, there's a demo today in the Dome C, so be sure to check that out. Now back to Brian.
Thanks, Ryan. So we've seen with nearby notifications that you can enable contextual experiences even if your application is not installed. Once your application is installed, there are a wide variety of contextual signals that your application can trigger behavior on. And to talk about this, Payam Paksad from the awareness team is going to go into more detail about awareness.
Thanks, Ryan. My name is Payam, and I'm the technical lead for Awareness API. So as you all know, Google offers a rich collection of contextual signals via various APIs. These include things like fuse location provider, activity recognition, place detection, geofencing, nearby messages, as well as a lot of information signals about the state of the device, whether screen is on or off, Wi-Fi scans, and so on. So while on the surface, these signals all look like quite different in the way that they're produced, they actually, each one of them tell you a different piece of the common story about the context of the user, where they're at, what they're doing, what's around them, and so on. So this common theme is rather lost in the way that developers today, without awareness, would have to collect these separate pieces of information from various APIs and put them together to get the full contextual picture. So last year, we introduced Awareness API, which offers a common and simple to use interface to access all these contextual signals and to seamlessly combine them in a way that gives you a more powerful experience. What's more, actually, awareness does this in a manner that's power optimized, and it manages its own impact on battery life and data usage. So, in a sentence, for us, Awareness API is a unified sensing platform, enabling apps to be aware of all aspects of users' context while still managing system health for you. We currently offer the following contextual signals covering different aspects of users' context, including things like where they are with location and semantic places, what's around them with nearby beacons, temporal context with semantic times, things like whether it's a weekend or afternoon, what they're doing with activities, and interesting device states like whether headphone is on or not, as well as interesting information about the ambient conditions, weather in particular. As Brian mentioned, Awareness offers access to these signals in two ways. Our Fence API gives a callback style access, while our Snapshot API gives a unified polling style access. As far as Awareness fences go, you can think of them as a generalization of geofences, where you actually get a callback when a specific condition on users' overall contextual state is met. This is especially powerful because now you can easily combine these various and disparate signals into a single custom-made and semantically meaningful condition that's actually custom-made for your app and your use case. I'll show the power of this with an example in the following few slides. So suppose you're writing an app that's interested in the event that the user is close to a particular place of interest on a sunny weekend or holiday morning. So just think for a minute about all the steps that you would have to take to make something like this to happen. And here it is, how easy is it to do this with Awareness? You can first set up an Awareness time fence for the event that it is weekend, similarly one for event that is holiday, and another for event that is morning. All of these, by the way, are localized to your current location. You set up another Awareness location fence, which is around the place of interest that you're interested in. Once you have these fence objects, you can combine them via Awareness fence language in a very natural way. You can almost read the sentence as, this is the event that's it's weekend or holiday, and it's morning, and you're near that particular place of API. If you're interested in more than a single place of interest, you can just as easily extend this API by passing in a collection of location fences and use awarenessfence.or of all these things. Once you have your fences set up, you have to register it with Awareness. And the way you do it is you create a fence update request object. You need to pass in a fence key that identifies the fence you're interested in and a pending intent on which you're listening for the trigger events. And you finally register it with the system. At this point, you're ready to receive trigger events. Your receiver may look something like this. Notice that multiple fences can be registered against the same pending intent. So you'll have to check that the fence key that you're receiving trigger event on is the one that you're interested in, and the current state is the one that you're reacting to. In my example, I mentioned weather, so you can access that just as easily with our Snapshot API with a single line. So this gives you the current weather at the current location that you're in. Now, I want to emphasize that Awareness not only makes doing all this very simple, it actually does it in a way that's power and resources efficient. So for example, in this scenario that I just mentioned, Awareness will cache and store information about the local weather conditions, as well as weekend and holiday models. And we'll share it across all the apps on your device that are interested. So this will save on using unnecessary network calls. Another facet of this is that Awareness uses a smart evaluation algorithm on the combined fences so that contexts that are costlier to produce are not produced until they're actually needed. So since last year, we actually added some great new context to make the Awareness API even more powerful. In particular, we've added some semantic time context conditions to our time fence. Some of these I already talked about in the example. In addition to things like parts of day and weekends and holidays, you can actually now create conditions, fences around the solar times, that is sunrise and sunset. And I want to emphasize again that these are set up at the location that you're in. So awareness takes care of updating the actual values as the device moves to different locations. Our snapshot API is just as easy to use. It gives you a very quick access to a fresh sample of all the signals that we are offering, like places, weather, beacon states, and so on. So since last year that we launched our API to public, many of you have started using awareness in very creative ways, and I wanted to spend a couple of minutes to showcase a couple of interesting use cases by our partners. The first example is Stocard Card Assistant that I think in the last session you actually heard a little bit about as well. So this is an app that lets the users digitalize their loyalty and rewards cards and stores them in a digital wallet format. So what they found was that users often actually forget to use their loyalty cards at the moment of at the shopping point at the moment that they need to do it. So they've used the combination of awareness fences, awareness context, to come up with a way to estimate the exact moment that users need to be accessing these things and remind them with a single click access to pull up this thing. Another great example is QuickBooks Self-Employed. And this is an app that helps users track business expenses for tax deduction purposes. And they use a combination of awareness context to accurately estimate the business-related mileages. And as you can imagine, this is a hard problem, and you can only get a good picture by combining a different set of contexts at the same time. In the area of digital fashion, this is an app called Coded Couture by Ivy Revel, which actually creates a unique and personalized design based on users' daily life. So what they do is that they use awareness signals like places, weather, and activity, and translate them in a creative way to fashion designs for personalized dresses. So with that, I'd like to hand it back to Brian. You can find a lot more information and examples about our APIs at our developer site. And please come talk to us about how we can make awareness work better for you. Thanks.
Thanks, Payam. So with awareness, you can really trigger contextual experiences that take advantage of a bunch of different signals, combine them together in a way that preserves battery power. One example of a context that we think is really important is proximity to other devices. Since we announced the Nearby Messages API a couple of years ago, we've been really impressed by the things that people have built with it. We've seen applications that allow you to explore your world. We've seen applications which allow you to connect with the people closest to you in your life and share things with them. And we've also seen examples of second screen experiences and games taking advantage of this API to do really cool things. We've also had a lot of feedback from developers about the kinds of things that you would like to see in the future versions of the Nearby API. And we've been working really hard, especially over the last year, on bringing some of these things to life. And so I'm really, really excited to introduce Varun Kapoor, who's going to talk about how we're taking the next generation of Nearby's APIs offline.
Why? Why does it take me more than one click to share an article I'm reading with my coworker who's seated 2 feet away from me? Why does it take more than one click for me to share the image search results of poker hand rankings with my poker group every Friday night? Or let's raise the stakes and set a slightly more elaborate scene. I'm in downtown SF, where finding parking on the street is rough, even on a good day. And then I see this. It's after 5 p.m., but it's the 31st Tuesday of the year. but it's a leap year. But the stock market was down today. Do I park here or not? I don't know. I look across the street, and I see 5 driveways sitting empty, waiting to be parked in. I also remember that I have an app on my phone that lets people rent out their driveways. As luck would have it, I'm in an area of SF where I have weak cell signal. So as I wait for the long round trips to the server, back and forth, I sense a darkness in the force as I feel the sound of the last chocolate eclair at my favorite bakery getting sold out. It's too late. Why could these houses not just advertise the availability and rates of their driveways? So my phone could scan for them and query all of them and book the one that makes more sense for me in a completely offline fashion. Taking it one step further, if I'm late getting back, why can't these houses then query my car, which will tell it that I'm just a block away, so I can avoid being penalized or towed? I'll tell you why. Because implementing these features entails dealing with the vagaries of Bluetooth and Wi-Fi across the cross product of A, the range of Android OS versions out there, and B, the variety of hardware out there. What these apps back then needed was a reliable, performant proximity platform that abstracts away all this complexity and leaves them free so they can focus on just adding the features that matter to their users. Now, at this point, I think we all know where I'm heading, and there can be only one thought racing through all your minds. This guy has got one rockin' do. While that is kind of you to say, and veritably true, allow me to be a cautionary tale. This, boys and girls, is what happens when you spend a year working on building exactly this kind of platform. The radios have commanded their sacrifice in the form of my hair and my tears. Oh, so many tears. OK, now that we've established the big bad of our story, it's time for our heroine to come riding in to save the day. Nearby Connections is the next step in the evolution of Google's Nearby API, an API that started with Nearby Messages as its V1 offering, but which also quickly limited its own reach by A, requiring a connection to the internet, and B, providing a programming model that has proven to be clunky in all but the most simple of cross-device interactions. Unix doesn't provide a pub/sub API as its lowest level abstraction over the network. It provides sockets. And now, so does Nearby. In a nutshell, Nearby Connections enables the advertising and discovery of nearby devices, as well as high bandwidth, low latency, encrypted data transfers between these devices in a fully offline P2P manner. It achieves this by using a combination of classic Bluetooth, BLE, and Wi-Fi hotspots, and it leverages the strengths of each while circumventing their respective weaknesses. For instance, Bluetooth has low connection latency, but also provides low bandwidth. Wi-Fi hotspots have slightly higher connection latency, but also provide much higher bandwidth. So what we do is we connect over Bluetooth and start transferring data instantly. But in the background, we also bring up a Wi-Fi hotspot. And when that's ready, we seamlessly transfer your connection from Bluetooth to Wi-Fi with absolutely no work required by the app developer. With that, let's look at the flow of the key primitives of the API. An advertiser called Start Advertising, and sometime later, a discoverer called Start Discovery. Soon enough, the discoverer is alerted to the advertiser's presence by means of the onEndpoint_found callback. If the discoverer is interested, they can call request connection. This is the end of the asymmetric part of the API. And from here on, everything is completely symmetric. Both sides get an onConnection initiated callback that gives them an authentication token they can use to verify that they are indeed talking to each other. Upon out-of-band verification, they can both either call accept or reject connection. And when each side gets the other's response, we invoke the onConnection result callback. At this point, the connection is either established or it's not. From here, either side can send payloads by calling the send payload method. This leads to the other side getting the on payload receive callback, followed by both sides getting a series of on payload transfer update callbacks up till the transfer reaches the final state of success or failure. Finally, either side can disconnect at any time, and that leads to the other side getting the on disconnected callback. Aside from that, there's a couple more concepts in the API. We support 3 kinds of payloads. Bytes. These are byte arrays of up to 32K, and they're typically used for sending metadata or control messages. Files. These represent files on the device's storage, and we make sure that we transfer from the application to the network interface with a minimal amount of copying across process boundaries. And streams. This is good for when you need to generate data on the fly and you don't know the final size upfront, as is the case with recorded audio or video. As I mentioned earlier, we use multiple radio techniques to advertise, discover, and establish connections. And the combinations of interactions of these techniques are codified in our strategies. Strategies are named for how far they'll cast their net to try and find a nearby device, and what kind of connection topology they will enable. And right now, we have 2 of them, P2P star and P2P cluster. As the names might suggest, P2P star makes sense for when you want to enforce a star network with a 1-to-n connection topology. And P2P cluster makes sense when you want to allow for slightly looser m-to-n connection topologies. For example, a classroom app where the teacher wants to host a quiz for all the students, that would probably be best modeled over P2P star, with the teacher as the one advertiser and the students as the end discoverers. And that same classroom app could have a mode that allows students to break out into ephemeral project groups. This mode, where students want to drift in and out of multiple groups, would be best served with P2P cluster. Now, let's see how all this can be put together in an undoubtedly harmless mock application. In a world where the machines have not yet taken over, and you feel compelled to write a fun little app to make your collection of drones self-assimilate. But Varun, I hear a voice ring out in concern. Why would I want to do that? That's for the machines to know, and for humanity to eventually find out. For now, let's just let this fly. So, as I was saying, in that world, since we want every drone to see every other drone nearby, we'll make both of them, we'll make every drone advertise and discover at the same time. Because we want them to exchange some small control information before making any larger decisions, like what to do with these puny humans, we'll make them instantly connect upon discovery of another advertiser. And we'll have both sides auto-accept the connection, like so. Once they are connected, that short control message we spoke about could be modeled as a bytes payload. In our case, we'll let's say, perform a quick leader election algorithm. Words we will surely live to rue. And finally, the leader can send a stream payload back to the follower that allows sending constantly changing updates about his current location, so they can move in lockstep with military precision. What could possibly go wrong? Now, that was the simple base case of 2 drones. Applying mathematical induction and generalizing to n is left as an exercise for the reader. But by and large, your end result should look something like this. At this point, Brian has insisted that I assure all of you that I absolutely do not have an army of pre-programmed drones sitting in my garage, armed and ready to take flight at my slightest whim. So move along, folks. Nothing to see here. While we wait for the day that our benevolent robot overlords grace us with their cold metallic probes, we have some slightly less bone-chilling uses of nearby connections spotted in the wild. The Weather Channel is using nearby connections to build a pretty darn cool offline mesh to help spread urgent weather updates and warnings, especially in the wake of natural disasters. Send Anywhere is a South Korean app that allows sharing files intelligently in the most efficient manner possible, regardless of whether you're online or not. And they're using nearby connections for their offline modality. Pocket Casts have been a great partner for nearby messages, and they now want to enable people sharing and discovering podcasts in a completely offline manner. For example, when you're stuck in an aircraft and are looking to crowdsource your options for entertainment. Game Insight is a leading game developer, and they're using nearby connections to not only find nearby players, but also to run their games completely offline. Again, being stuck in the inside of an aircraft comes to mind. Hotstar is India's fastest growing streaming network, and they're using nearby connections to allow offline sharing of downloaded movies and TV shows. So you don't need to have access to the internet. You only need access to a friend who does. And finally, Android TV is about to launch a new remote control app where they use nearby connections to not only set up your new Android TV and configure it to be on your Wi-Fi network, but also to serve interactive second screen content in a streaming fashion. Oh, and before I go, there is one more thing. That APNP, pay and park idea I spoke about back there, whichever one of you out here makes your billions by bringing that to life, please at least send me a postcard from your private island so I'll know that this was not in vain and this happened for a good cause. Thank you.
Thanks, Varun. I'm really nervous about these killer robots, but I'm sure it's all going to be OK. So the Nearby Connections API is going to be available really in a couple of weeks in a new version of Google Play Services. And we're really excited to see what you're all going to build with that. Please keep giving us feedback about the kinds of things you'd like us to do with Nearby. We're really excited about your use cases, and we want to make the API better. There's a wealth of information on our developer site about all of our APIs, awareness and Nearby. There's a bunch of examples, sample apps, reference implementation. Please join our mailing list. We'll send you updates when the APIs are available. And I just want to say a big thank you to all of you for coming here. I think we can build really great apps together, and thanks very much.